everyone, my name is Putu Diah Pratiwi and my student ID number is 211301111. I'm from class 4D Mathematics Education. In this video, I would like to present about set. Humans often sort things according to their type, such as clothes, pants, book, plates, glasses, etc. In mathematics, we do the same thing to make it easier. A collection of particular objects that have a clear definition we call a set. The definition of a set is a well-defined collection of distinct objects called elements. In the set theory, a set element can be anything like people, letters of the alphabet, numbers, shapes, variables, etc. Previously, I explained that the definition of a set is a well-defined collection of distinct objects called elements. What does this definition mean? Let's discuss this now. In the definition, it is said the set has well-defined properties. In mathematics, well-defined means that we can determine whether an object belongs to a set or not. For example, a group identified as the set of even whole numbers between 1 and 11 is well-defined because it is possible to find the exact members of the set, like 2, 4, 6, 8, and 10. There is only one possible solution set that fits this description. Another example of well-defined set is the set of integers from -3 to 3. This set contains -3, -2, -1, 0, 1, 2, and 3, and only those integers. On the other hand, the set of lucky numbers is not well defined because it is open to interpretation. It is unclear from the description what lucky means and what has to happen for a number to be considered lucky. There are any number of possible solution sets. In the definition, we also find the word distinct. What does that mean? Distinct means that we do not replicate the same object in a set. For example, if we have two sets, A and C, which one between A and C is a set? Yes, you are right. A is a set because all its elements are written only once. But C is not a set because elements C, 1 and 3 are written twice. So C is multiset, not a set. For we can better understand about the set, here I present some examples of set. Number 1, the set of students in this class. Number 2, the set of counting numbers greater than 5. Number 3, the set of days in a week. And the last, the set of vowels in the alphabet. Now, let's talk about set notation. Have you seen the notation like this? Do you know that notation shows what? Yes, you're right. That notation shows a set. Set notation refers to the different symbols used in working within and across the set. The most straightforward less set notation is the curly brackets, which are used to enclose and represent the element of the set. The elements of a set are written in the curly brackets. The elements of a set are written and separated by commas. Capital letters are usually used to designate sets. Elements of a set are usually designated in lowercase letters. After we learn about set notation, we now talk about element notation. Let A be a set. If X belongs to A, we write like this, which read X is an element of A. To denote Y is not an element of A, we write like this. Example, let A be a set of counting numbers less than 5. Then, 3 is an element of A. 6 is not an element of A because 6 more greater than 5, and 3.5 is not an element of A because 3.5 is not counting numbers. Now let's talk about representation of sets. There are different set notation used for the representation of sets in set theory. They differ in the way in which the elements are listed. The three set notation used for representing sets are: first, semantic form; second, roster form; and third, set builder form. Let us understand each of these forms with an example. First is semantic form. Semantic notation describes a statement to show a set's elements. For example, a set of the first 5 even natural numbers. The second is roster form. The most common form used to represent sets is the roster notation, in which the elements of the sets are enclosed in curly brackets separated by commas. For example, set B with element 2, 4, 6, 8, and 10 is the first 5 even numbers collection. In a roster form, the order of the elements of the set does not matter. For example, the set of the first 5 even numbers can also be defined as 2, 6, 8, 10, 4. Also, if there is an endless list of elements in a set, they are defined using a series of dots at the end of the last element. For example, infinite sets are represent as X with element 1, 2, 3, 4, 5, and so on, where X is the set of natural numbers. To sum up the notation of the roster form, please take a look at the example below. And number 3 is set builder form. The set builder notation has a certain rule or a statement that explicitly describes the common feature of a set's elements. The set builder form uses a vertical bar in its representation, with a text describing the characters of the elements of the set. For example, A is a set with element X, element natural number, where X is less than or equal to 10 and X is even. The statement says all the elements of set A are even natural numbers that are less than or equal to 10. Now let's talk about visual representation sets. For representation of a set in visual ways, you can use Venn diagram. Venn diagram is a pictorial representation of sets with each set represent as a circle. The elements of a set are present inside the circles. Sometimes a rectangle encloses the circles, which means the universal set. The Venn diagram represents how the given sets are related to each other. Let us observe a Venn diagram example. Here is the Venn diagram showing the correlation between the following set of numbers. One set contains even numbers from 1 to 25, and the other set contains the numbers in the multiples of 5 from 1 to 25. The intersecting part shows that 10 and 20 are even numbers and multiples of 5 between 1 and 25. Now I would like to tell you about the cardinality of a set. The cardinal number or cardinality or order of a set denotes the total number of elements in the set. Symbols of cardinality are like this. To more understand about cardinality, let's see this example. Number 1. Set A with element 1, 2, 3, 4, 5, 6 has cardinality 6. Number 2. Set B with element A, B, C, D, E has cardinality 5. And number 3. Set P with element Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday has cardinality 7. Now I would like to tell you about the types of set. In this video, I would like to share there 9 types of set. Number 1 is empty or null set. Number 2 is singleton set. Number 3 is finite set. Number 4 is infinite set. Number 5 is equal set. Number 6 is equivalent set. Number 7 is disjoint set. Number 8 is power set. And the last is universal set. Number 1 is empty or null set. A set that does not contain any element is called an empty set or a null set. An empty set is denoted using the symbol like this. The examples of empty set are: first, the set of triangles with 4 sides, the set of integers that are both even and odd number, and number 3, the set of odd numbers divisible by 2. And remember, the set with element empty set is not an empty set because the set has an element that is empty set. Number 2 is singleton set. A set with only one element is called a singleton set or a unit set. For example, set A with element k, where k is an integer between 3 and 5, which is A element just 4. Number 3 is finite set. As the name implies, a set with a finite or countable number of elements is called a finite set. Example, set B with element k, where k is a prime number less than 20, which is the element B is 2, 3, 5, 7, 11, 13, 17, and 19. Number 4 is infinite set. A set with an infinite number of elements is called an infinite set. For example, the set of whole numbers. Number 5 is equal set. If two sets have the same elements, they are called equal sets. Example, set A with element 1, 2, 3 and set B with element 1, 2, 3. Here, set A and set B are equal sets. This can be represented as A equal B. Number 6 is equivalent set. Two sets are said to be equivalent sets when they have the same number of elements, though the elements are different. Example, set A with elements 1, 2, 3, 4 and set B with element A, B, C, D. Here, set A and set B are equivalent set since cardinality set A equal to cardinality set B. Or we can write NA equal NB. Number 7 is disjoint set. Two sets are disjoint if there are no common elements in both sets. Example, set A with element 1, 2, 3, 4 and set B with element 5, 6, 7, 8. Here, set A and set B are disjoint sets. Number 8 is power set. A power set is a set or group of all subsets for any given set, including the empty set. A set that has n elements has 2 to the power of n subsets in all. For example, set A with element 1, 2, 3 has a total element 2 to the power of 3 equals 8. And the power set of A is like this. The last is universal set. A universal set is the collection of all the elements regarding a particular subject. The universal set is denoted by the letter U. Example, let U with the element the list of all road transport vehicles. Here, a set of cars is a subset of this universal set. The set of cycles, the set of trains are all subsets of this universal set. And this is the source of the presentation material that I took. And that's all from me. I hope this video is beneficial for you and see you in the next video. Bye bye.